Hi everyone. So people were asking some questions about the experiment we did on Friday, about Rutherford's experiment, and basically wanting to get a little bit more information about what I meant by the ratios I was using, and how I basically did the math to arrive at the answer that we got. So, under the assumption that a lot more people probably have the same question, I thought I'd just run through it real quick for you all here. When I use the word ratio, I literally mean fraction. So fraction, ratio, also percentage. I find percentage to be a useful way to think about what we're trying to do here. So ratio, fraction, percentage, they all basically mean the same thing. So you can think of it like this. We want to know what percentage of balls that we throw bounce back at us. Okay, so that's what we were looking for on Friday. That's what Rutherford was looking for. What percentage of balls that we throw bounce back up at us? Because we literally equate that. So percentage of balls that get backscattered, we literally equate that to the percentage of the screen that was actually blocked. Okay, so that's a sort of a logical argument we make. We don't actually derive that, but we can think about it in a few different ways. Imagine this is the screen that we had on Friday, and imagine there was nothing there, just totally empty, no balls, nothing in the way, and I asked everyone to throw really any number of balls through it, and I would ask, well, what percentage was backscattered? And it would be 0. There would be 0 balls backscattered in that case because of the fact that there was nothing blocking the screen. So if 0% of that screen is blocked, then 0% of the balls we throw are going to get backscattered. Likewise, if we imagined a case where let's just block half the screen. So let's put something covering half that screen that we've got. So over here on this left-hand side, it's wide open, nothing there at all. And over here on this right-hand side, it's totally blocked. So in this case, you could say that it is 50% blocked. So it's half blocked. The ratio, or the fraction of this screen that is blocked, is 50%. So, in terms of ratio terminology, or actually let's use the word fraction in this case. The fraction that is blocked is half, and the percentage that is blocked is 50%. They mean exactly the same thing. Ratio, we can put some numbers to this. Let's just say that the horizontal dimension here is 200 centimeters, so 2 meters. And let's say it's square, just to make things kind of a little bit easier. So it's going to be 200 centimeters tall, 200 centimeters wide. So in terms of what's actually blocked, the horizontal dimension down here is only blocked halfway, right? So we're blocking 100 centimeters of the 200 total. And the vertical dimension here is the full 200. So in terms of the ratio of what's being blocked, really, again, the same sort of thing, we say, well, what's being blocked? Well, the part that's being blocked is 100 centimeters times 200 centimeters. So that's going to look like that. Over the total, which is 200 by 200. So that's just 200 squared, centimeters squared. And so really, these all mean the same thing. The ratio, I've just actually put in some numbers to it just to be a little bit more specific. But if you do the math on that, that just works out to be exactly 1/2, or 50%. So, you can think of it in all these different kinds of ways. And the important point, once you put all that math together, is this bit at the bottom. How the percentage of balls that get backscattered is exactly the same as the percentage of screen that is blocked. So in this case, 50%. So if we were to throw, I don't know, it really doesn't matter how many balls we throw. If we threw 1,000 balls at this system, I can tell you right now that 500 of them would be backscattered. And it's simply because half of the screen is blocked. And so if there was any other fraction of the screen that is blocked, say 10%, if you block 10% of the screen, then 10% of the balls you throw are going to be backscattered. And that's the logic of that experiment. So if we kind of imagine a system like we had on Friday, a little bit more like the one we had on Friday, it would have looked like this. So in this case, again, our screen is blocked, and it's blocked by a certain percentage. And the challenge that we had on Friday was the fact that we didn't actually know what percentage of the screen was blocked. That was kind of something we were trying to figure out, because we didn't actually know what the size of these little balls were. We didn't know what the size of our simulated nuclei were. So the diameter there, we didn't really know. But we do know that the percentage that is blocked should be exactly the same as the percentage of balls that get backscattered. So what we could do pretty easily is just measure the amount of balls that get backscattered. That's the part that we can do just by throwing the balls, just taking a measurement. So we were able to figure out this percentage, which then by definition told us what that percentage was, which then allowed us to calculate that number. So I don't have the exact numbers here that we used in the classroom, but I do know that the total area of the screen was somewhere in the range of about 23,000 centimeters, give or take. I don't have it exactly right there, and I do know that the total area that was blocked, or the area of the screen that was blocked, was equated to all of these little circles that we've got there. We had 36 of them, and there are 36 in this diagram. Made sure of that. So we got 36 circles, which we know have an area of pi d squared over 4, and that d is the same one. And so this is what we've got that is blocked right here. We don't know d, but that's fine, because we'll measure it using this relationship down here. And so again, you can think of these ratio that we're looking for as a percentage. So what's the ratio that we're actually looking for? Well, the ratio is, again, just like we did up here, it's blocked. Let's go here. Blocked right here over the total. That's the ratio. So the percentage of this screen that is blocked will be the 36 times pi d squared over 4 all over the total area, which I'm just going to ballpark it as 23,000 centimeters. So that's the ratio. That's the one we're looking for. And we know that it's going to be the same, thanks to this relationship down here. It's going to be the same as the percentage of balls that get backscattered. So that's why I asked everyone to remember whether they knew that a ball got backscattered or not, because that was a really important number. The number of balls that get backscattered allows us to calculate what this percentage is, or what this ratio is right here. So I'm not sure what, there was a different number for each section, but let's just say that there was 8 balls backscattered out of a total of 262 thrown. There you go. We've got our ratio. So 8 over 62 is the same percentage as the percentage of screen that was blocked. And because there's an unknown here in D, in terms of the percentage of the screen that was blocked, we could just work it out by calculating this ratio or percentage right here. So that's how it worked. You can fill in these numbers and work it out yourself, just a little bit of algebra, but that's how the logic of the whole thing works. And that should be about it. So if you have any other questions, feel free to get in touch. Send me an email, or make a comment on Moodle, and we'll get your questions answered for sure. See ya.